We are a KW hydroponic farming. I'm Wyatt.
I'm Aiden.
I'm Keegan. And here's our problem statement. Ford Farm's hydroponic farm users globally struggle with maintaining a constant pH level of 5.5 to 6.5 in their crops. The lack of optimization in the system caused a significant decrease in the crop yields. Fluctuation in the plant's pH levels is due to their inconsistent nutrient and water uptake. Their crops naturally sit at a pH of 7 or higher. The process to lower these pH levels to their desired need can take anywhere from a few minutes to a few hours per week.
For specifications for the criteria, we wanted to it needed to be one continuous flow, constant flow through the whole system by using a 0.5 horsepower water pump, and the down solution, pH down solution, would need to be able to evenly go to each farm, and then the system would be able to need to connect to 5 flex farms, and simple things like easy to clean, easy to move, and easy to drain and measure the pH. And then for constraints, all the water must stay at the same pH level throughout the whole system. Space and cost efficient, needs to be able to be moved and cleaned and drained.
We want to create a set of benchmarks that will just ensure that our product will be improving the original system. So we came up with the manual input must be reduced under 2 hours per month. pH levels do not fluctuate outside of range. It needs to be easy to use, and the pH reader accurately reads pH levels and adjusts with the right amount of pH up solution or down solution.
These were our initial designs. Mine involved a centralized tank there on the left, and it was very efficient at reading the pH, but not very cost effective because there was a pH reader and memo sense at each one.
Mine, in the middle, was placed in a circular pattern, had very good water flow, but poor pH down concentration.
Mine was very similar to Keegan's with the circular design, but in the centralized tank, and it was inefficient because of the even or uneven pH distribution each flex farm. And then with our final design on the left picture, starting the top right, the pH solution tank is where pH down solution would be put into with 2 solenoid valves to stop backwash through the system. And then it'll go through the pump into a bigger tank that'll just kind of hold water. And then we have 2 sensors, one at the started system and one at the back, to just ensure that we're getting the numbers and the reads that we're intending to. And then it just flows through all that 5 flex farms and back through. And then on the right, it shows the memo sense and channel transmitter within the design.
Here's our flow chart. It mainly just shows our solenoid valves and our pump in the system, and where our 2 pH sensors are placed.
This is our CAD design. So basically we have a memo sense right here that's reading the water, and then we have our 2-channel transmitter on the side of the pH down solution tank. And then we have our tank up here just to make sure that the pH down doesn't get diluted when it flows through all the flex farms. And then there's a close-up of the 4-channel transmitter, or the 2-channel transmitter, and the memo sense in the side of the pipe. And then these were the products we used. We used the memo sense CPS 77E. It's approved for hygienic and food industry standards. It's low maintenance and simple. We also use the 2-channel transmitter Liquiline CM442. It includes a transmitter and indicator and displays the pH digitally for users.
And then for cost analysis, schools being the biggest buyer of flex farms in general, because they have about $1.8 million they spend on leafy greens, lettuce type things, and that's about 16% of their whole food spending is just on lettuce. And our design would be $7,500, and with the flex farms, it'd be $32,500. And this would be able to like benefit them. They're already spending a lot of money on lettuce, and this would help them be more efficient. For example, it'd be less labor. You wouldn't have to add pH into each system. It'd just be automated through all of them. Instant pH readings without having to read each farm individually. And then also even distribution, and then just constant flow between the systems. And then they'll be like, we estimated to be like a 20% higher crop yield from like using normal flex farms to using our system.
Thank you. Any questions? Yeah.
How'd you get from the 3 different ideas? What was your decision process to get to your final concept?
So basically, we saw that our 3 ideas we wanted to make sure we had a tank. We didn't want a tankless item, and then we needed a pump to get through it all. And it's like they're 3 really different designs, but our final design was just, it felt most efficient to get the pH evenly distributed and cost effective, while also making sure we don't have air with the 2 memo cents. Any other questions? Yes.
I love that you did a parallel design with your water returns. Was there any constraints or requirements to monitor each individual tank if one of them went south and corrupted the whole system?
I don't think we had any constraints to make sure they run out, or if they run out, but you just manually go put in the pH down into the tank.
You would have the like sensors of the water going in and out, like reading the pH. So you kind of just manually add it based upon that.
Any other questions?
Thank you very much, guys.
Thank
Appreciate
you.
it. Thank you.